Hello, everyone. Welcome to Mining Now. I'm your host, Jared Downey. Today on the show, we are doing this is part three of the three-part series that we've been doing with Micromine, featuring Micromine Elastri. Today, we have Chris Nguyen. He is the technical pre-sales manager for mining at Micromine. Chris, welcome to the show. It is great to have you on.
Oh, welcome. Thanks for having me.
Yeah, this is going to be a technical talk. We're going to cover a lot of ground. I know you're an expert in the field, so I'm going to try to hang on, and I'll probably ask some pretty simple questions. I'm going to skip to the end very quickly. There's going to be a payoff here, talking about the scale that mines can save, getting rid of unnecessary mining costs in this. So that'll be the teaser for the audience, but we're actually going to walk through it with the audience. It's going to have a lot of depth and give the audience a good idea of what Micromine Elastri is actually capable of with your experience. So with that in mind, can we just start? What is your background in the mining industry?
So I've got over 10 years of experience. I started working with Rio Tinto iron ore back in 2011, 2012, primarily doing short-term planning and a lot of design engineering work. So I spent about 7 years at Rio Tinto, and I developed the first initial models in the Micromine Elastri Tactical Scheduler Forum. Once I was done with Rio Tinto, I wanted a bit of a change of pace. So I moved and changed positions, and I started working at AMC Consultants, which gave me a lot more experience in the long-term mine planning and mine scheduling space as well. So that gave me quite a bit of exposure. So I started off as a regular mining consultant there, and I finished my time there as a senior mining consultant with a varied amount of experience in different commodities, and I was also exposed to due diligence work and corporate projects as well. Once I was done with AMC, I joined Micromine as a support and product specialist to get exposure more on the technology side, and I'm pretty much where I am now, about 2 years down the line.
Did you with Rio Tinto? Did you say you had worked with Micromine Elastri already?
Yeah, so Micromine Elastri at the time made some products which began with, I believe, Hall Infinity and then Rapid Reserver. And then when they made the tactical scheduler, they needed people to test it, do incremental rollouts on a site-by-site basis. So I was actually involved with that.
I've got to ask, because I don't get to ask this question that often, because you got to work on both sides of it now. How much has it evolved since the day one of when you used it to now?
It's evolved quite a bit since then. So having to work at AMC, I basically lost access to the software. And when I was doing the retraining when I first started as a product specialist, I was a little bit blown away to see how much has changed. Things are a lot smoother. File sizes, which used to be large, are now a lot more compressed. And there were just a lot more new features. So sending up reports was actually like quite a lot easier compared to what it initially was. In terms of the development cycle, the developers have always been really fast with implementing new features, bug fixes, improvements. And I could easily see that it's definitely come leaps and bounds as well. And it was already a very good product back when I've initially used it as well. And it's hands down probably one of my favorite bits of software.
It's we're going to cover a lot of ground here today, so it's nice for me being able to just ride the coattails of people like yourself who are experts, and I get to sit here and then just basically get free lessons. But I wanted to. You mentioned tactical planning. Now we've done episodes. We've done a fair amount of episodes about strategic scheduling planning on the show. When you say tactical planning, can you sort of differentiate between the two and walk us through it?
Okay. So just a little bit of background. Whenever there are mine schedules around within a company or for an operation, there are actually multiple horizons or multiple types of plans. So the typical way of categorizing them would be you have your lower level short-term plans, which can be weekly, monthly, and then you have your longer term plans, which would be, quarterly, or perhaps like once every couple of years. And then as you start going to the higher level horizons and you get more of a big picture view, you eventually end up in what's called the strategic space. So tactical plans are typically shorter, from maybe the 2 year, and even some of the life of mine plans and shorter. And then the strategic plans are very holistic, all encompassing, and will usually utilize a different type of software in order to execute it or to do the scheduling. And they will basically encompass the entire mine life, perhaps, but also take into consideration a lot more, a wider variety of constraints.
These two plans are they? Do they need to align, or how aligned are they, or is that sort of what we're trying to trying to get to here?
Ideally, those two types of plans should align. So, regardless of what planning horizon, whether it's two different shorter term plans, or if you have a tactical plan and a strategic plan, all of these plans should try to align as much as possible, under the proviso that the higher term plan, is the main thing to follow and is done correctly. When these things aren't aligned, so if there are differences or misalignments in the multiple planning horizons or the two different strategic and tactical plans, what you get is you get mining sequences which start to deviate significantly. So your strategy is being eroded and is being destroyed, which can also lead to loss of revenue, loss of profit. You might be paying more penalties on the ore and the product that you ship out to your customer. You can also lose sight of what your original goal is, which again increments all of your mining costs, and it just reduces the amount of agility that you can have as an operation over time as well. And so, yeah, as a culmination of not meeting targets, straying from the plan, not delivering, it really affects the business quite significantly.
When you say mining sequences, what do you mean? What would examples of those sequences be?
That's a good question. So a mining sequence is just basically, what pit or what stage you want to mine at a particular time. So an example is, should you mine X amount of tons from pit A and then Y amount of tons from pit B? Sometimes if you have like a planned deviation, you might do the opposite. You might mine in the wrong places just in order to hit an ore tonnage target or something like that. But it has downstream effects because the quality of your product or the final product after processing the ore is quite significantly different. And you can probably tell that if you start mining in a completely different sequence by mining certain pits more than what was originally planned, there will come a time further down the line where it will affect your overall mining strategy and your holistic mine plan. Mine plans do get reforecast, but to sort of absorb all of these deviations to some degree. But the important thing to understand is that the end customer at the end of the value chain will be affected, and there are financial implications of not receiving the specification of product that they initially wanted.
That's a reference to penalties you were talking about.
Yeah. Correct.
Is it how? Where is the big struggle in aligning both your tactical and your strategic?
So there are a lot of sources for plan misalignment. So in a practical sense, at the execution level, you can have unexpected downtime from your mining equipment, and also just accidents can happen as well. Things that you can't really control, or maybe you control them at like a maintenance level, something that's within the operational space.
So what would be an example of that would sort of disrupt? Like an accident would be like a conveyor shut down, or are we talking what would be?
It could just be tires bursting on a haul truck, which takes out the entire haulage route. I've seen haul trucks sort of just catch fire and you just have to let it burn out before you can move it. And I've been on the receiving end of having to publish a plan which immediately got superseded because of those accidents.
Right.
So I mean, things like that can happen. If you have an increased unexpected downtime, or things are starting to break down more often, you have all of these other programs that you can do, like implement more preventative maintenance and all of that stuff as well. But those are all operational level issues that staff on site can try and resolve. In terms of the planning space, things are a little bit different. So plans can misalign due to a variety of factors in terms of the differences in input parameters. So sometimes departments can be a bit siloed, so information isn't flowing between two departments, and some key assumptions might be missed. Some other companies, depending on their scale, will rely on consultancies, a bit more, and a consultant will do the mine planning and the mine scheduling, but you still have an exacerbated problem where information might not flow through properly, and then you add time constraints and budgets into the mix, and then you can easily get a plan that might look good, but it might not be as executable as you'd initially think, and so that causes a deviation from the shorter horizon or execution level plans as well.
The strategic plans look good, you mean?
Fun.
The strategic plans look good, but on the tactical side, it's much more difficult to implement because of these basically misalignment or even miscommunications between divisions or shutdowns or anything like that.
Yes, correct.
Right.
There's also a bunch of other things as well. One of the other probably key factors as well is, in a world where everything is very time constrained and very busy, we get mining engineers who can't, they can't get the time to actually learn software packages in depth, whether it's our packages or another competing package out there. And sometimes, once you've understood or got all of your input parameters, implementing them into your actual scheduling model is also the next step as well. So you have all of those potential sources of misalignments.
This is what you just brought up about things like for me, I have seen just in even our little company trying to implement a piece of software. It is so, and we've got people, I guess all over the world, working on different elements of our company, editing and booking and advertising and all that. And just you implement one piece of software, and it's hard. If one person does it wrong, it's really, really a challenge. You must see that in the mining industry in just such a grand scale that, I mean, you're probably seeing people still working off Excel sheets sometimes, trying to align everything up. I'm guessing that, but I feel like is that a major hurdle that a lot of companies are dealing with?
Absolutely. So starting at AMC, it was my first time being exposed to just not using an actual software package for my long-term plan. But they applied it in a correct sense as well. So if you're doing something at a very high level or scoping level study, you can use an Excel spreadsheet. And sometimes Excel spreadsheets can get quite sophisticated, but sort of like what you were alluding to before, let's say you do implement a software or you have like a good spreadsheet or something like that. Transferring that knowledge from one person to the next and getting everyone on board is the next hurdle that you have to try and overcome as well. And, it's not really enough to just have a nice model and then, have it be completely inauditable or extremely hard to learn. And then, some people will probably take like a scheduling model in whatever form it's in. And then, because they don't understand how it works or how to maximize the use of the software or the spreadsheet or whatnot, issues with implementing new constraints, differences, or changes in input parameters will be difficult, which will again just exacerbate the problem of plan misalignment.
Right, because they're having to. So the plan can be good, but as soon as they start tweaking it, there's almost is it almost like a domino effect where it just starts to get more and more complicated to sort of align it with your strategic plan?
Oh yeah, absolutely. It works both ways as well.
Right.
So one thing that we find more often than not is um, usually the strategic plan has less detail compared to the tactical plan because they're just looking at the bigger picture, right? When you zoom in at the lower level, you get the nitty gritty detail. All of a sudden, there are site level issues which need to be reincorporated upstream into the strategic plan.
Mm.
So what we find is that the tactical schedulers will have a system or like a user experience which allows them to incorporate these changes relatively easily, but it's much harder to do it in a strategic scheduling package,
Mm.
which is the way that it's written and set up is quite different because it's more holistic, big picture.
Right.
And so when you start entering in very fine-tuned details, it's a lot more difficult.
Can we kind of try to bring this into a real world scenario? Is there any examples that stand out to you? And I'm not asking you to use mining operators' names or anything like that, but just is there an example you can sort of walk us through that to the listener can kind of paint a picture of a real world scenario where you're trying to either align the strategic or the tactical, or you're trying to basically organize the tactical within the strategic.
Okay, cool. So I've got two examples, and I'll try to keep them a little bit brief and concise. So the first example that I've got is of a shorter term plan affecting a higher or a longer term plan. So these examples, by the way, are something I've personally experienced as well. So in this example, we I was working at an operation where we finished mining out one particular bench in one particular area, and we had to move on to mining the next bench. Now, one of the geologists and operators saw that there was still ore mineralization in the wall, in the final wall, after it was battered and scaled. So basically, what that indicated was that there was still presence of more ore to mine if we drilled and blasted further in. The decision was made because to drill and blast the additional area because more ore tons just helps out, right?
Yeah. So this is
And
an
so we drilled.
unplanned. This is an unplanned
Yep.
mining then
Yeah.
operation. Yeah. Okay.
Yeah. 100%. So it wasn't in the original design. It wasn't originally in the mine plan, but there's upsides to it. So we drilled, blasted the material, and then we dug it out. And we all thought it was great. It's just unscoped high grade that we got into the crusher, which helped out with product delivery. But as a consequence, and it's something that you never really see unless you take a step back, maybe I don't know, months later or perhaps even years later. In order to do that drilling and blasting and digging activity on that out of design ore, we held up the development of the next bench. And so we basically, in order to get, say, for example, 100 kilotons of high grade, we held up the development of I don't know, 2 million ton bench, which was relatively complicated to, drop into and just start your next mining phase. And we basically took that on the chin, as we always do. And we just chalked up to, it's something else. But not realizing the fact that our previous decision to hold this up gave us this problem further downstream.
Right.
And it's very hard to kind of see or appreciate, what the consequences of certain actions actually do.
So
That's
just to clarify the example. So because you went after that ore, essentially the new target, basically you couldn't bring out enough high grade from that area that would justify putting time, money, workforce into that area as opposed to moving over, or what caused that discrepancy?
So basically mining all of the outer plan stuff held up the ability to mine the next bench, which required a lot more tons to be moved. So rather than say spending the time to mine, say, the extra 100 kilotons of high grade ore, which was out of design, out of plan, we might have been able to have moved, more waste quicker from the next bench, which would give us better access or faster access to, say, for example, the 500 kilotons of high grade, which would be needed, in 1 or 2 weeks' time down the line.
Right.
So
you actually drop the production line, the amount of
yeah,
production happening going
yeah,
through
that's
the
exactly
plant.
it.
Yeah.
So sometimes we kind of get blinded by the prize, and we
Mm.
turn a blind eye to the downside risk, which is the opportunity risk, right? And it's sometimes hard to see that.
Yeah.
So that's the yeah.
I was just going to say, now everything in me now wants to say, okay, Micromine Elastri, let's plug in how that would have, how that plugs in. But you said you had a second example, so I'm going to get you to jump to that before we jump into the Micromine Elastri section.
Okay, no worries. So the second example I had is about a strategic level plan sort of affecting the shorter term plans. So what I saw in one of the subcontracting jobs that I was doing was I was working with my client, and we were having a look at vetting some pit designs and the block models associated with it. So we had a look at our pit design, and it required additional waste movement from, a land bridge, or like a lot of loose material from a big giant haul road, basically. And we were having a look at it, and I was trying to just make sense of it, like why we had to move all of this extra amount of waste, just out of curiosity's sake. So I had a look at the block model, which is like a 3D visualization of the ore in the shape of many, many blocks. And I found that, there was a reason the design scalloped out a little bit, and it was to just target like 4 blocks or large blocks of ore. But when I had a look at the block model codes, even though it was flagged as high grade, the resource classification flag for it was flagged as unclassified. So for those of you who don't know about resource classifications, you have measured, indicated, and inferred, which where measured is the highest rating and inferred is like the lowest classification that you have. And it just basically says or indicates what level of confidence a person has, or the block model has, that that particular chunk of or block of ore is actually there. So unclassified basically meant that there was probably some historical information in there, but not enough ground truthing has happened in the area, like probe drilling or whatnot, to validate its actual existence there. And so basically what my client was looking at was potentially spending a couple of $1 million just mining out a bunch of waste to mine some ore blocks, which might not even be there. So again, there's a reason for this as well. When you're doing a strategic level plan, you can't just write everything off.
Right.
You have to account. Yeah. You have to account for the ability that, that your operational team can do some ground truthing, and then you'd modify the designs afterwards. But this one slipped in somehow, and it wasn't culled back. And so there was a risk of it just, of the operational team just going ahead and just mining off waste and trying to target that blindly.
How often? I mean, I know this is going to be a guess, especially when we're talking about data and accuracy. Now I'm asking you to guess at something, but how often do you think that happens? Because your strategic planning has outlined something that those type of resources are put into an area of mining something like that. Do you like, does it happen at every mine at least once? How often do you think? If you were just to guess.
Oh, at a guess, I think that would be a bit of a rare example.
Mm-hmm.
That instance or that situation kind of baffled me a little bit. I just don't know
Where it happened. But in both examples, though, where now to go? I mean, the series is about Micromine Elastri, so I'd like to tie it back in. Where again, and keeping it as real world scenario as we can, in both those scenarios, where does Micromine Elastri fix those issues? Where does it come in?
So in the first example, Micromine Elastri can assist by trying to hold schedules to task. And so in the software itself, or in the Elastri tactical scheduler itself, it is possible to try to account for the additional out of design ore by making a new solid and then incorporating it into your plan. Um, and then what you can do is you can do scenario splitting to see, you know, if you took that, if you mined out that block, um, what would your forecasted, or how would that affect your bench turnover delay, and how much will it delay mining the next bench? And it could figure that out quickly with its inbuilt rules and all of that. Because the ore is out of design and out of plan, it's already obvious it's a deviation. So, um, you know, our new uh, our new strategic guidance feature won't really affect it that much there. In the second example, with the out of design ore, you probably do have like a very similar instance where you'll have to do some scenario splitting as well, and that will quickly identify, what the effects of mining those other areas and stuff would be as well. As part of the Elastri Tactical Scheduler, you get a rapid reserving module. So the client should have been able, would have been able to see that kind of discrepancy by interrogating the block model, which is basically what I used in order to have a look at it. So and just verify that those issues existed there.
So you're able to look at them as in different scenarios to say, like, again, I've had to apologize many times on this show for layman questions, but if you could say, okay, we're going to this block of ore that we're thinking about mining, what if we only mine half of it? Like, how specific are we getting? Are you running different scenarios to try to decide if you should have mined it? In the first scenario I'm talking about, mined any of it, or is it just you're running scenarios to say we should or we shouldn't? Like, I'm just trying to understand what the end user, what they're essentially inputting, and then what the output is, or what they're getting back from that.
Okay, so in terms of capability, Micromine Elastri can cater for, completely mining out the additional bit of ore that wasn't spotted, or it could be like any partial proportion. So Micromine Elastri's tactical scheduler is pretty flexible. What you're doing as the end user is just putting in a number, which is targeting that additional bit of out of design ore or whatnot. And you can just explore very quickly by just rerunning the same scenario and just having a look at what the downstream effects is. Or you could just split scenarios if you want to do that, if you have certain proportions in mind. So the software is quite flexible in that regard.
So are they doing, like, I saw one chart here, it almost, maybe I'm wrong, and we can bring it up and then you can correct every wrong thing that I say. There's one with sort of, we'll call it a red rim around it, and then one with a purple rim. But they look like the same ore body. So are we looking at a strategic versus a tactical on this chart?
Yes, that is the one. So that chart that you're referring to is part of a presentation that I did at the Elastri user conference. So probably one thing to just give clarity on. The first two examples that I gave before was more or less a tactical versus tactical situation. Whereas what you're seeing on the slide right now is, Elastri, Micromine Elastri's tactical scheduler interfacing and trying to comply with a strategic mine plan, which was done in our other software, Micromine Beyond. We have a strategic scheduling package in there. And so basically what you're seeing is Micromine Elastri has a new feature called strategic guidance. So once you're done with your strategic plan, you can export the face positions, or a triangulation of where your mine plan needs to be, or where your mining surface needs to be at certain periods in time. Once you've imported it, once you've exported it from your strategic scheduler, you can import it into the Elastri tactical scheduler, and the red and the purple wireframe outlines that you can see are basically the anticipated mining floors or the mining surfaces from the strategic scheduler. So what you can see is when we enable this feature, we can incentivize the Elastri tactical scheduler to mine in compliance to those wireframes. And the picture on the left, which is the one in red at period 5, you can see that there is some compliance there. So the mining blocks, which is in the brown color, is being depleted in order to try and match that red surface. The best picture to kind of cast your eyes to is the image on the right, which is period 9 with the purple wireframe. And you can see that there's this rendering artifacting. So there's like a mixture of purple and green and it looks all stringy. That basically just indicates that the top of the mining blocks is flush with the end of period surface, which means that it is complying with a high level of accuracy. It's like flush.
Sorry, when you say compliant, you're saying the strategic plan, it is giving you the parameters that, okay, the mine has to operate in this way. It has to mine. Now, if we're doing it this month or next month, that may be up for debate, but this portion has to be mined, essentially.
Yep.
Right. Yeah.
Yep. And so basically what you can see in those images is the strategic guidance or the strategic, end of period surfaces is saying you need to have mined at least this much by, the end of period 8 or the start of period 9. And you can see through the absence of the mining blocks in the Elastri tactical scheduler, it's basically hit that target. So you can see that
it's amazing.
The tactical schedule is aligning to the strategic schedule, given the same assumptions.
So putting this together, what is the end result? If you were to compare, let's say Micromine Elastri is being input into both those scenarios or into other scenarios that we're talking about. What are we talking in numbers wise, in time wise? What would you, if you want to use those examples or another example, that's fine. What do you think we're talking about in numbers in preventing these types of essentially errors in the tactical side of things?
No, that's a good question. So with the new strategic guidance feature in the Elastri tactical scheduler, the outcomes of improving the plan conformance can be seen in multiple ways. So Micromine Elastri has another product called spatial conformetrics, which other clients use quite a bit as well. If you implement the strategic guidance feature and feed in, your strategic plan or even a tactical plan of a higher horizon as part of, your shorter term planning process, and use the guidance feature, what you'll see what you should see is that as you start trying to execute more plans, and then you start using spatial conformetrics to reconcile, your actuals versus what you've actually mined. The plan compliance number should be increasing because your shorter term plan should be targeting, the same areas as your higher term plan or your longer term plan. Now, the other metric that should increase is like within that you can see in spatial conformetrics as well is, the mined in plan, and then you should see less, out of mine or out of schedule planning. So again, that's another, although a bit more complicated metric to kind of have to kind of spot and see. Now, in terms of real world use and what the end user might experience is rather than having to try and rebuild their scheduling model to account for all of these other assumptions and the different ways that, the longer term schedule project works, rather than having to go through like an extended complicated setup, which introduces human errors as well, and also more sources of non-compliance and uncertainty, we have a simpler system to just import these end of period surfaces from perhaps like another Elastri tactical scheduler project. And then you can just use that, and it just takes out a lot of the overhead in terms of the user experience and the entire setup. So once you take that load off of your mine planner, you also give them a bit more time to actually focus on the issues that do matter. So you've got, your operational issues, which you know you have, and then you have a clear face position, which you can use, and Alashri can now incentivize itself to actually mine towards those imported surfaces and face positions. So again, just makes it easier. You can sort of focus on the more operational issues that might pop up last second, without having to worry about all of this additional logical rebuild that you'll experience from a longer term project. So the last thing I also want to mention as well is not all plans are perfect, and not everything will go perfectly, every time you run a plan. So if, for example, you're doing a short-term plan and something goes inexplicably wrong, like you have an equipment breakdown, right? It's important to note that the strategic guidance feature isn't going to just solve all of your issues, because if the high-term plan says that, say, a machine is available, but it isn't because of an unexpected malfunction, what the strategic guidance feature can let you do is, rather than deviating significantly in order to just catch up and react, what it allows you to do is it allows you to respond in a more appropriate and measured manner. So rather than deviating from a plan significantly, what it can give you or show you is another way to move forward and to be behind in the right proportions, rather than being significantly behind in one pit because you have gutted out another in order to catch up. So then that way, you don't quickly or as quickly compound your deviations. So it just gives you a bit of more of a chance to catch up in the following plan, where you have a bit more overhead equipment availability, and whatnot as well.
So I just want to make it just again for real world scenario for someone like me trying to figure it out is so let's say you've got your haul truck fleet, then one breaks down, then it could be a matter of saying, okay, well we're mining on this part of the pit. Let's shift this over because now we can haul the same amount with less trucks. So for this amount of time, we should be hauling from this location. Is it something like that? Would that be a real world example of where you'd shift over, or do I kind of have it off a little bit?
It's very similar. So in your example, so let's say you're supposed to mine like X amount of, like, say, 1 million tons from one pit, and say one or two trucks break down, you won't be able to achieve. There's a good chance that you won't be able to achieve that target, right? Because you're mining that 1 million tons of ore from that pit. So 1 million tons of total material from that pit, maybe to get, say, 500,000 tons of ore, for example.
And that'd be part of the strategic plan, right?
Oh, yeah. That or like the tactical plan that you're trying to adhere to. Right. Oh, but yes, you're correct. The higher level plan. Now, what happens in practice more often than not is they'll go, hey, we need to get 500,000 tons from that particular pit, but we're like a couple of trucks down. So what we can do is we can mine pit number 2, and we can get 250,000 tons, or half the required amount, and it might be a quicker haul or something like that. And so rather than having that deviation, what you can do is you could potentially try and realign your strategy or the tactical plan in order to try and get a little bit more out and to maintain focus on your first pit. And then maybe you fall behind on another pit, which still needs to be mined, but as per the strategy or the strategic guidance wireframes that you have, maybe it is worth dropping that other pit off instead to maintain focus on this other pit.
Right. So the opposite of what I was going to do, essentially.
Yes.
So this is why you have it, because you don't have someone like me going, this is a shorter road. Just go over there and get some. Okay. Before I let you go, Chris, I want to ask. And this is not. We've interviewed lots of great softwares on the program, and that I just want to give the audience an understanding. And it's like sensor technology. Sometimes we have to compare them just so the audience understands what they're choosing between. How would Micromine Elastri differ from some of the other options that are out in the market for them? Where do you think it sort of stands out and delivers for the client?
Okay, so from my own personal experience from having used it, where I think the Micromine Elastri product really differs compared to other software packages that I've used in the past, to me, it's really the ease of use and the capability. If you look at software holistically in general and comparatively, I believe that the Elastri product is a lot easier to pick up. It's a lot more regimented in terms of its workflow, and things are just a lot more clearer. And I think, you can probably have the best software in the world, but if it's extremely difficult to use, um, you know, it's just not going to be usable on a day to day, on a regular basis. And you can't really get a lot of traction to get other people to buy in to use it as well. Um, so the user experience to me is the key thing. Things are clear, things are orderly, it's very capable. The way that it's set up is smart. It's got this new strategic guidance feature as well, and I think that Micromine Lastri's product is probably the first that I've seen that has that particular type of function. Um, and it's also very, very fast. Like, there is a specific use case for the Micromine Elastri tactical scheduler. It shouldn't really be used for strategic plans because um, that requires like a slightly different type of algorithm and programming and the way things work. But in terms of usability, that's what I think about Elastri.
What for onboarding it? What would you think? If you're training someone on it, I mean, obviously not someone like me, someone who's already up to date on this type of thing. How long do you think the training would take just to onboard it? Do you have like free trials that go on? What's sort of the setup if somebody wants to give it a try?
So training is relatively quite fast. So we do offer a 30-day or a 4-week trial. And typically what that would encompass is, a 2-week, 2 weeks of one of our consultants doing a bit of a model build. So if we receive your data, we will build part of the skeleton of the model for you. And then after the 2-week period, the initial 2-week period, we then hand the model back to the end user, who is usually like a site champion, or perhaps we can do, or sometimes clients would want multiple users trained up at the same time, and then we'll work with them as well. Now, this in the second half of the evaluation period, that is where our minor consultants and a client or a customer or an evaluator will work a lot closer. So they would come in, get the model handover, and they would sort of do the training for each of the constituent Elastri tactical scheduler modules alongside of it as well.
Sorry, go ahead.
Oh, sorry. Sorry. So the one thing I almost forgot is doing the Elastri tactical scheduler course, just to give an actual figure, will take about 4 days. So it'll be 1 day for the rapid reserver module, maybe 1 day for Hall Infinity, and then 2 days, around 1 or 2 days for the actual scheduling section of the software.
And that's within the 30-day trial that you'd be onboarding that? Okay, I think we might have a link that we can put in there. So if you're watching this as the audience, there'll be a link to, I believe, the 30-day trial in the actual video, and we'll try to include it on LinkedIn as well. Thank you for walking me through this, Chris, because some of the questions I asked are actually within is I've actually quite often tried to figure out, it's like, how do these how are these companies even choosing when and where, and especially tied in with that overall plan. So thanks for actually walking me through it in a way that I could understand. And yeah, I hope this is not the last time I interviewed because it was fun. I quite enjoy these really technical sort of actually go through the information, and from the engagement on our audience on these types of episodes, I know they do too. So thanks for taking the time to do this with us.
No, no worries. Thank you for having me.
And thank you, everybody from the Micromine team, especially Carla, who helps us organize these episodes, and Gowdy here in the studio, recording everything and setting everything up, and everybody else that's involved from both organizations to produce these episodes. There will be links to Micromine, of course, in the episode, but specifically the free trial and to Micromine Alastri. So to go check those out. There'll also be links to the other two episodes we've done on these topics for Micromine Alastri. So go check those out. Thank you, everybody, for watching, and we will see you on the next episode of Mining Now.